Hello everyone and welcome back to Behind Massive Screens, a game development podcast here from Massive Entertainment in Malmö, Sweden. My name's Dori, joined by my co-host Petter. And today we are going to be tackling a subject that neither one of us really has any in-depth knowledge on at all. So we are going to be putting ourselves in the shoes of, well, maybe some of you listeners out there that aren't really familiar, and we're going to try to gain a much deeper understanding of the subject as we go. So with that said.
Yeah, just be patient. I just want to briefly, I started sending you screenshots of another podcast studio that I found on YouTube with like couches, and it was a really nice, like comfortable chair, and their microphones, and Joel McHale was just like lying on a couch. Why don't we have that?
Well,
I want it so bad.
I think I would need to start the explanation with a short physics lecture, pointing out the space that we have in here. It may look bigger on camera than it actually is, but like sneaking in here and actually sitting down, it gets quite tight. So that would be the number one thing. Where in here are you going to fit a couch?
I fix it.
Yeah. Also, I feel, with both podcasts and video in general, as soon as you sit down on a couch and you slouch down, so does your general energy.
I just want a comfy couch.
Yeah, you're not going to get it.
Damn it.
Onwards to today's show. We have a wonderful guest here, Omar, who is a senior online programmer. So that may hint towards what we're going to be talking about today, which is, online programming.
Yes.
So I think let's start with the classic question before we get into lighthearted but deep discussion, as we always do. And that is, what does a senior online programmer do? Like, what is the function?
Yeah.
What is the function?
Yeah.
It's a programming joke.
Yep, exactly. We write code. Yeah, but like the term is a little bit of an umbrella term, because you get to do many things, but in general, it's more about making sure that, the players are able to connect to your game if it's a multiplayer game, and also taking care of things like, matchmaking, how the players connect with each other, how they are, how they join the same match, and, based on their skill rating and all that, and how they do voice communication, how the game state synchronizes between the different players, and so on. So all of these things, and you also get to communicate with a lot of different departments in the game development ecosystem. So animators, audio designers, a lot of things fall into place, and we can talk about that later.
So basically, any department that is making something, if the question is if needs to interact with other players, then talk to you.
Exactly.
I'm filled with programming jokes.
Yep. That's it in a nutshell, basically.
Yeah.
Why do we keep inviting people that are much smarter than us to this podcast?
Because that's the allure of the podcast.
Okay.
So, so the second big question that we always get out of the way right at the beginning is, your journey to where you are now. How did you end up at Massive, but also how did you get into this specific field of working within games?
Okay. Well, tighten your seatbelts. All right. So it really started, because of my dad, who was pushing me since a young age into games. Surprisingly, he was like pushing all the latest games my way. And at some point, in my childhood, I just figured that, I want to do something regarding this, like games or movies. And at that time, I was really fascinated by animation. So originally, I wanted to be an animator. And towards right before college, I was doing 3D modeling and, just character rigging and animation, but not crazy stuff, but, it's honest work. It's not much, but it's honest work. And I was really happy with that. But when I started going into, applying for universities and stuff, and I did not find the best curriculum, you could say. So the next big thing for me was like, okay, why not work in programming? So I might not be doing the animation, but I could be writing the programs that the animators use to make the animation.
Right.
So still have some fun with this. So yeah, I went ahead and went for a computer science degree. And I have to say that, I'm really thankful for my mom who helped a lot with this. And, and two of my amazing professors who were there from the very start. Professor Huaida, here's a shout out. She was the one who pushed me, like right from the start, from the second course. I was like, just telling her what's an integer, what's a float. I don't know if you guys have.
I know that.
Well, okay, explain.
No,
in depth.
Like basically the data types that you deal with when you're programming.
What Omar said.
So I was at that level, and then I was telling her, but I want to be a game programmer. And she was like, oh, yeah, sure. Yeah, go ahead and look in the library or something. So I went ahead on a searching journey, and then, I stumbled across Unreal Engine 3. But at the time, that was closed to big studios. So the only thing that was available was like Unreal Development Kit.
Right.
And I started using that thing, and, it had its own programming language, but it was nothing crazy. Like you can still map what you're studying in the course to that. And I just went ahead and with it. And at the time, Ubisoft had Tom Clancy's End War coming out.
Oh, yeah.
And that game was like, a mind-changing experience for me because, the whole voice control thing, you were able to control the units with your voice. So I went ahead and tried to integrate the Windows speech-to-text thingy. And I had something that kind of worked. And that was like during that time, very early on in the computer science degree. So that was fascinating for me. So towards the end, I managed to get some friends along, and then we worked on our thesis project on a crowd simulation engine. And that was also pretty good. And that's what made me, after graduation, I joined a game studio in Egypt. This is where I'm from. And then I worked there for a bit, and then, I said maybe it's time to discover, what's out there as well. And this is the interesting part, I guess, because I went into fintech. So it's not game development at all. And I worked in data science and data engineering there.
Right.
But you can say that, I learned a lot during that because I had to handle a lot of traffic from data coming in and analyzing all this stuff and, having this data served to a lot of users. So you can see it's kind of overlapping with the requirements in the game dev industry as well. But then I went to a game dev conference, and then I met a lot of people from the industry again. And then I was like, okay, I have to get back. And this is when I applied for Massive, and it's great to be here.
Yeah. And the rest is history.
Yeah. What was it with computer science? Was it just that, okay, there are no animator courses available, and so I just got to computer science? Or was there a moment where you thought, where it clicked, like, okay?
Yeah, there was not like a very like specific course or curriculum that I liked. You open the degree curriculum and you look at the courses, and not all of them are that interesting. And I was interested in more of the traditional animation, like, drawing stuff, and
right.
And it had
that's a pretty big leap then.
Yeah. It's but I'm not good with art or anything. That was my intention before, but again, it helped me a lot because now I can understand at least what the different teams are talking about, because I tried to deal with this before. Animation and the different programs like 3D Studio Max and Maya and all that stuff. But it is a big leap. But at the end, I found it more kind of impactful to be, from my perspective, to be working on enabling the artists to get what they want or what they have in mind, which can be really complicated if you.
I think sometimes it's easy when you think about game dev to kind of forget about that part. Like you think game dev and you think about the animation and you think about the game design, but sometimes like the tools actually somebody has to make them.
Yeah,
in
like
the first place.
And if you fire up any of the game engines and you have all these tools that enable you to do stuff visually and like in nodes and make it more like a visual way to work. But then you think, oh well, somebody had to not only understand what they wanted out of it, but then also had to program and make those tools.
Mm-hmm.
Which, yeah, that's
it's my. The rabbit hole just goes deeper and deeper and deeper.
And sometimes it's crazy because sometimes these people don't get the spotlight at the end.
Yeah, exactly.
Yeah, because the movie gets the spotlight or the game gets the spotlight, but the poor guy who had to write this code to enable them. So it's nice to think of the whole ecosystem, how it comes together, I think.
Yeah, because like when you think of games versus movies. When you're making a movie, yes, you need to dress up the set, but you're basically making everything out of real world things and shooting it. And then in game dev, you're making it from scratch.
Yeah.
But then what you're using to make that has to also have to be made, which is
we can sit here and just dig our holes deeper and deeper, or become all philosophical.
Yeah, or we can move on.
or we can ask more and more questions. But again, let's leap going from animation to computer science and coding. What was it with the code itself? Like, because obviously now you're senior online programmer here, so obviously something stuck with you. Yep. What was it with code and coding that kind of made you continue on that journey?
Okay. Oh, that's deep. Well, I think it's really fascinating. I've been working with computers for some time now, but to every day when I think about it, I'm writing some high level English language kind of programming, and then that gets converted in the end to electrical signals. So all of this gets, it's electrical signals. And that is fascinating for me, because, all this AI stuff and ChatGPT, matrix multiplications. And then at the end of the day, they're also electrical signals. So this interaction with the hardware, that you can just write something and then it magically becomes electrical signals that you can see on the screen with some direct feedback. That was crazy for me. And that's what kept me going and trying to understand how it works deep inside as well. Like from the operating system to the hardware, to the memory, how the processor communicates with the memory, how it communicates with the graphics card, with the network card, and all of these things. And it's such a magical thing when you get into it. But it's a rabbit hole, as you said.
Yeah, I love talking to programmers for that reason. We've done a couple of episodes about various forms of programming and programming in general. And I just find it so fascinating because basically any program you talk to have that kind of relationship to it. Once they've done it for a long time, something about that, like a philosophy of coding somehow. You think about it or it's easy to think about it just like text on the screen and then stuff happens. But for coders, more often than not, it's something more than that. It's almost like it's a magical thing.
Yep. I completely agree. And, it's also like, if you care about, the performance of your code and stuff, and then you start having to look into the mathematics of it. Mm-hmm. And this is when it becomes really beautiful because you can model a lot of things using mathematics in code, in programming, I mean. And even like really large systems and, how you can architect these systems together. And it's just fascinating. And the coding is not usually the greatest thing. Like at some point you start, I love programming, but it's not the only thing that you care about. You start caring about the whole architecture of things, right. How they fit together, how can you make these systems modular? How can you, make them fault tolerant? What if the system crashes? How can it recover? Something like Google, how does it keep going forever? And with people attacking it and everything. How do you survive with all of this? So this is the thing that, you start thinking about it more as you progress in your career. And it's always fascinating.
And then we're moving it online as well.
Oh, yes. Because, we want to, like you said, we've done some episodes on programming itself, but we want to focus on, online programming. And I thought I'd open it up by, not a dumb question, but a very, very basic question. And that is, I play a lot of games, and the one thing that you always see out there as a complaint from gamers, and I'm guilty of this myself. I miss a headshot, and immediately I go, bad netcode.
Yeah.
So first of all, what is netcode, and how does it work?
Yeah. That's the problem is this netcode thing is only something that I think it's only there on the internet. There's no textbook that you can open up and find netcode as a scientific term. But that's what the culture is out there. People use that word, but it's like a big umbrella term to what is going on here. So it's a bit complicated, so we can maybe talk about the different parts that contribute to it.
Absolutely.
So you have your, starting with the connection in your home. If you're using Wi-Fi, if you're using Ethernet, that can affect it because, with Wi-Fi, if you have your family using it as well, then, it can affect the signal, and then that can affect also the traffic that your computer is sending out on the wire. So that's one thing. So use an Ethernet, maybe that helps. The second thing is usually where you are in the world. So where you are geographically in the world. So if you're trying to connect to some players in Europe or the US and you're in the Middle East, for example, then of course you'll have a lot of latency because these packets have to travel across continents sometimes.
All the signals need to meet at some central location, which is going to be physically further away from somebody.
Exactly. And the whole thing with the internet is that its intention is to deliver this data, but not in the fastest way. So it can make you take a very long route as long as you're going to reach your goal. That's what its intention was, and that's what since it was invented, that was the case. But we're still using it today, and we want it to work with speedy stuff. So that's the problem then. So that can take a long time if you're, as we said, if you're in different continents, and sometimes you don't even guarantee that it's going to reach there, the end destination. So you have to repeat this work, and that can increase the latency that you experience. So one way to fix this would be to start game servers near your players, but you have to have a large player base there so that you start this process and all of this. The very last part of this netcode scenario is how the architecture of your game is set up. So you can hear stuff like client server architecture or peer-to-peer architecture and these kind of terms, and that does have an effect as well on how you perceive this netcode situation. So for example, peer-to-peer games, which some of them are implemented that way, all the different players have to all the time synchronize with each other their state. So some games like, RTS, like Age of Empires or any of this category of games, they work usually with something like the peer-to-peer architecture. And all the clients have to synchronize. And, if you're lagging, you're bringing everyone down with you, like waiting for this player to finish their turn or something.
So the speed goes down to the lowest common denominator, basically.
Yep.
Exactly. And sometimes they also have they run a very deterministic simulation. All these animals moving in the world and all the different physics and everything, that's running with a deterministic simulation. So everyone is having the same kind of simulation run on their machines. And that is also synchronized. So if somebody falls behind, everybody has to rewind and resynchronize again so that they move to the same state. But sometimes this player can get really out of sync that it completely fails to recover. And then the whole game closes or the player is kicked out and everybody's unhappy.
Right.
So that is one thing. But that doesn't explain the bullet thingy.
No.
So
well, sometimes.
yeah, if it's running that way. But yeah, there is another way, which is the client server architecture. So the server is the one that has the authority over all of our actions, and we are basically when you shoot something, the game will simulate it locally for you, so that you get the direct feedback right away. I shot this person. All right. Have all the bullet effects and all the blood effects and everything appear for you. But if the server decides after you send this information that the other player is not there in the first place, then it will correct it for you. And then you'll be like, oh man, why didn't it hit this person? I shot the whole magazine at this person and nothing happened. So you get that effect as well. And that can be part of it due to latency from other players, or the server itself being completely overloaded, that it's having delays sending these updates.
Yeah, or a lower tick rate.
Yeah, exactly. So that is something. The server sends data not necessarily at 60 frames. It can be sending it at 10 frames sometimes. And on the client side, on the player side, it's only doing predictions and like estimating where the other players are. So, if you get this effect of people running indefinitely sometimes and, jumping off a cliff or something, or, going down the map. And this is all because of this prediction code that sometimes if it's too severe, it can show up in all of these crazy ways.
That kind of brings us to the cooperation. I still think that haven't really touched on the online programming, moving from what we were talking about before about creating these tools for other people to use, and then to the online part. Now we've talked about netcode now. But I think this kind of brings us into your job as an online programmer to work with the other teams, to work with gameplay, for example, to make sure that these things are at least minimized.
Yeah.
Like how does that cooperation between you and other teams, your team and other teams, look generally?
Yeah, it starts really by, of course, the game team having the idea for their gameplay and stuff. And, and then we can think about what's the perfect architecture, the same thing we talked about right now, that would work for them. And then this architecture would sort of dictate how they also implement their gameplay code and their animations and stuff. So, we have to communicate with gameplay programmers because, they will be coming for us saying, well, I have this attack, this weird ability, and it's a combo kind of thing. And I wanted to execute correctly and replicate to the other player. So they see this thing. And then we'll have to communicate on how we can do this kind of work together, So it's not us who are implementing all of this all the time. It's like sometimes the online programmers are only they only care about how the bytes are sent over the network, but we have to provide the API or the interface to the gameplay programmer so that they call us in a very easy way, and they don't have to worry about, oh, this byte arrived early or this byte arrived late and so on. And you can also be talking to animators. So something like this peer-to-peer architecture thing, if your game, we talked about this deterministic simulation thing. Sometimes you'll have to force the animations to be certain number of frames, for example, for it to work. So you'll have to be influencing other teams, just by taking an architecture choice, for example. And sometimes you have to keep doing these trade-offs between them arrive at the best thing that would satisfy everyone.
Yeah, has there ever been a situation where a gameplay programmer comes to you and have this idea and you go, no, that's not going to work, like physically with the information being transferred?
No, I mean, that's the beauty of our job is you try to get it to work. And the thing is, sometimes you might make some like kind of sacrifices, and you might not have the full kind of idea of what they had in mind first, but you eventually arrive at a solution that is in the middle ground. So yeah, sometimes, maybe it would be like, I want to send this information, per character in the game, but then you would be like, okay, but what about, you batch some characters and send all of this information at once? Might be better. So you are trying to sort of influence their way of writing the code as well. But yeah, there hasn't been a part where, you're like, no, this can't be done, because that's part of the problem solving situation that we do as programmers.
Yep. So how let's go down to basics. We tend to ask this question as well, but I think it's an interesting one. Like, how do you start working on a thing like this? If I come to you and say, okay, so I want character A to be able to shoot a character B, everything is going over the internet. Where do you start? Where do you come in, and where do you like start figuring out, okay, so here's where my job starts and here is where it ends? Okay. If that question makes sense.
Kind of. I'll try to answer it in the, in the area.
Again, where that's what I said. We have no idea where about any of this.
Yeah. So I mean, well, first of all, the gameplay programmers will be working using a game engine. Can be whatever game engine. So you will have to make sure that the technique that you're going to use to transfer this information is already is in the engine or not. And if it's not, then that's the first step. You'll have to be integrating that to the engine so that people can use it later on. And yeah, then they can come to you and say, okay, I want to shoot, as you said, shoot this weapon at this character and so on. So you probably can, try to explain it to them what they need to do exactly. But it's more of you will provide them with some library or some interface that they can communicate with that is a bit higher level than what we are doing at with online programming. So as I said, they don't have to worry about the certain number of bytes that are being transferred. They will just come to you and say, here's this object that I want to send. And how does that happen is that, this object or this bullet or character that you're trying to transfer over the wire, that is made up of just bytes in memory. And what happens is that, what the code we write is usually it takes these bytes and, tries to compress them in the best compact form possible, right, yeah, and then sends them over the wire. So that stuff is kind of transparent to the gameplay programmer. He doesn't have to worry about any of this. They will only be kind of concerned about, okay, does this replicate to all the players in the session, or does it replicate to a certain player? Can I make it replicate to a certain player, for example? I don't want things to be replicating to myself again. I'm the owner of this. I don't want to the network or the server to be sending me my own information,
taking up bandwidth.
Yeah, exactly. So this kind of questions probably they will be asking, how to do this in the best possible manner and so on.
Right.
And of course, you can be helping with things like, giving some directions on. Not everything has to be synchronized all the time. So, if it's a huge map, for example, and, there are stuff happening in the background way back, it doesn't have to be sent every frame, for example. So you can be sort of trying to help with these kind of details. And I think this is what we end up doing. But that is only the part related to the bytes transfer part. So there's a lot of other things like integrating game analytics, for example. That is part of what we do as well. Taking care of the databases that store the information of your saves and the game sessions and all of that. So that's also part of what online people do.
Yeah, and then you also mentioned voice chat and matchmaking.
Matchmaking, yeah. So that's a big rabbit hole as well, because you have to take care of, the player skill ratings, and that's a big topic that people usually have debates over, and on Reddit posts and stuff. Oh, are they taking my player style into this and stuff? So I don't know the exact details of things, but yeah, you take into account player ratings, you take into account their distance from other players. So you don't want to matchmake somebody from the end of the earth to somebody else. So all of these kind of constraints leads to what can be considered an optimization problem from a computer science perspective. You're trying to optimize the best kind of match. And it gets complicated because the more constraints you add, the less the pool of players you have.
Right.
And then they will end up waiting forever sometimes.
And then you have, different platforms, PC versus consoles, and cross-play or not, and how do you match them together?
And if you turn off the cross-play, then you're in a bad situation because you're only restricted to that pool of players. But that's some of the stuff that is considered online. So as you can see, there's a lot of different things, and sometimes you have to write in different programming languages, for example, and different frameworks to be able to handle these different things. So it's not like, sometimes it's completely agnostic from the game engine or technology that is used. And we have multiple in Ubisoft, for example.
One thing I thought about, we should have other examples of stuff. So it's like shooting things, exploding barrels, gun sounds. We should have the person wants to pat someone on the shoulder or like hug them. How does that synchronize across the server?
So
something like that. And if you're just to keep in mind for the future.
Yeah. Okay.
No, but what I was thinking about when you talked about like giant maps and synchronizing players, one of the first things that pops into my mind is EVE Online. The spaceship MMO, where they have so many players in battles. We're talking thousands of people. I remember 4,000 was a record, and then they just keep adding because people just keep
as soon as there's a record, let's get a couple more people in.
The EVE Online players we're gonna have a bigger battle than that. I don't know what they reached now, but since they have so many dots. If you ever seen one of these battles, it's chaos.
Yeah,
but they slow down the server. Like instead of trying to deal with all of that you were talking about now, like synchronizing all 4 to 10,000 players at the same time, they just slow down the server until they reach, I think, 10% of game speed.
Okay,
I think is the least they can go down to.
Yeah, that actually sounds like a feature to me.
It is.
The more epic the battle, the more slow-mo it's in.
Yeah.
Until it adds to the dramatic
until
effect.
You've been at your computer for 4 hours and your ship has moved. Like,
yeah. Anyway. I mean that is one way to fix the problem, is to not be sending updates at a very frequent rate and a huge amount of updates as well, because there's only a limit that you reach on your computing hardware, and the only option you will have available is to increase the resources that you have, but that will increase the cost as well. So that is a big problem, because our job is to try to cut the cost of these things, because and sometimes because it's wasteful kind of computation as well. You don't really need to be sending everything all the time. You can at least simulate some things, and some of these games might have this kind of deterministic simulation thing going on, which only requires like just a few inputs, because I could be just sending some sort of synchronized time between the players, and this synchronized time can can start like a random number generator, and that random number generator can generate chaos that you think is random, but it's not at all. It's completely controlled, and it's only synchronized between us with a very little amount of bytes being sent over the network. So that's one trick of doing it. The trick with the lower frame rate on the server. And and then you start getting into things like, trying to do multiple servers running and communicating with each other, but making it seamless so that people don't think that they are, communicating with people from other servers. They're just, it's happening as if it's, as if we're all in the same place, basically. And yeah, there are a lot of details in that area.
Yeah, I think, and you mentioned it before, the word, I think netcode is one thing that people tend to say, and then there is the word tick rate.
Yeah.
Or the term tick rate. It's interesting. In some games, you can actually see it more in action. If we compare like games like World of Warcraft, Final Fantasy 14, they move very differently. Now I'm just using MMOs again.
Yeah, you can tell that we play vastly different games, because if I were to come up with an example, I would say CSGO.
Yeah, well, sure. But I'm the tick rate of those two games is so different. That's my excuse for talking about my favorite genre. But I have this, one of the senior online programmers here as well explained this to me once with drawing a big thing on a whiteboard after a meeting. It was a lot of fun. But what is like tick rate? What does that mean in the context of online programming and online games?
Okay, well, yeah, that is sort of like what I was mentioning with the frame rate part. So, there, like a normal game loop, it would be running at a certain tick rate, which, with modern games, it's usually 60 frames per second. And that's the tick rate. But that's only valid for like, simulation purposes. Like if you're rendering things to the player, that needs to be at a high tick rate, basically. But the server doesn't need to tick at that amount. So it can receive inputs from players and then run a specific simulation, like did that bullet actually hit that surface or not, and it do all the math required using raycasting and everything, and then reply to the players with that information, and then the players can sort of, they will just simulate it right away. But what you see with the tick rate thing is that, the server can send information about the other players' movements at a much slower tick rate. So it only sends every 10 frames or so. And then on the client side, you have to just kind of interpolate this movement using the current position and the direction that the player was heading, and then you can sort of simulate how they are running. You don't need to have all this information being sent for every single frame during that motion.
Right.
So that is, and it works not just for motion; it works for a lot of different things that affect the gameplay. So simulations being one of them, like physics and stuff. But yeah, I mean that's I think the most useful example is the player motion thing. Yeah. So all the game engines out there, they do kind of prediction, and that prediction can be good or bad depending on how you write it. But yeah, if like things like packet loss and all of this terms that get thrown around in the netcode scenario, like jitter and packet loss and all of this can also affect the kind of prediction that will happen, because if you're not getting enough data to do your interpolation correctly, then you will find weird things happening, like you go fall in the map and stuff like that. Not you, but other players, you see them falling in the map or going through the wall and stuff like that. And once the server sort of gets back to you with the correct information, you'll find them snapping back to where they should be, and then that breaks the immersion or the fun of the game, of course. That get the tech rate part?
Yeah,
or?
I think that covered the question. It's just fun to kind of go into these like terms that so many people use, and Dory's obviously guilty of.
Like when you're talking about like server architecture and how it works, server versus client, like I hate to say it because it kind of maybe shows off my IQ a little bit, but back in the day, like if we take CS:GO for example, like when you're playing, you can see the viewpoint of your character, and then you can go into spectator view and kind of move the camera around freely and look at the map. I thought that is what the server is. Like the server is just, simulating the entire game, every single person, with the graphics and everything, and we're getting kind of view of that output.
Yeah. No,
but obviously that is not what's going on.
You're just getting some positions and like the current speed of that player, the ID of the weapon they're holding now, kind of like really primitive information. And then the game client, the game basically running on your end, will try to do its best to simulate using this information, whatever you're seeing. So yeah, it can get really messed up.
So like, for example, in a multiplayer game, say that there's an explosion right here. What the server is doing is saying there's an explosion and it's located right here, and then sends that information to all the players, and locally the client will then simulate that explosion
exactly
for each and every one of them.
But here's an interesting fun fact, that not all the time these things are transmitted. So in a lot of this networking code, you'll have kind of a best effort approach to things. So something like the explosion or, the muzzle flash on your weapon or something that is sort of cosmetic in a way, it doesn't affect your gameplay. Sometimes if there's a huge bandwidth congestion, it might not even travel. So you might, you find that you hit somebody or, an explosion happened and everybody's like, oh, that was amazing. And then you did not see anything, but you got affected by it. Like your health got reduced because this is the critical gameplay.
Yeah, or you got the kill.
Or you got the kill, but you never saw the muzzle flash or the blood decal or, blood splatter showing up because the server never sent you anything about that. Yeah. And then you're just wondering what happened here,
So is that also like a part of the online programmer's job, is prioritizing what is critical information and what is going down the line? Is like, this would be nice to have, but if you don't, they'll survive.
You kind of provide the framework for it, but probably that will be more of the gameplay programming who's actually saying, oh, but this is critical for the gameplay or not. But yeah, you sort of provide the kind of capability for them to actually say, I want this to be transferred reliably. And this thing, okay, do your best effort for it to reach the destination client. If it doesn't make it.
Although I have a feeling that might be some meetings, after some Q&A testing. It's like the gameplay programmer's like, everything I make is vital. I mean.
Yeah, everything is important. Everything has to be there. Yeah. That's what you try to get to. But once you have 200 players or like EVE Online, then you start sort of sacrificing that because, in the middle of the chaos, you don't care about this explosion happening way in the back or something.
No.
Yeah.
I also love the physics and coming to the electric signals that we talked about before is, we talk about like, okay, so the information is sent to the server that will then run a simulation and send it back. When we talk about it in these terms, it sounds like it takes a couple of seconds.
Yeah,
but we're talking milliseconds here.
Yeah, we're talking milliseconds here, but I mean,
it's just fascinating because it simulates. It's like okay,
it's traveling continents and stuff, and
exactly.
It's just milliseconds.
Like,
but I mean, if you're playing some casual game, you don't really get affected by that. And a lot of different games, like different genres, they don't really suffer when you have a very large ping, which is the latency basically. But if you're, competitive CSGO player, then you care about, I saw this person right now and I shot the bullet. It should have hit his head. Why didn't that happen? And yeah, sometimes.
But I'm just wondering more for your line of work or the online programmer. You talked also about optimization before. That I guess you must have this constantly in mind when writing the code. Like, okay, this code that I'm writing now, it can only take a couple of milliseconds to execute.
Yeah, I mean that is a big concern, of course, because our code has to run somewhere on the server, and it has to run probably next to the game code as well. So we're taking some budget, and they're taking some of the other budget on the whole PC, but we are also concerned with the bandwidth optimization. Right. So, a Boolean, for example, in programming, it's a byte, and it's basically 8 bits. So sometimes you can maybe use each bit for a different kind of flag or information. So you don't have to say, you can use a Boolean to say this is true or not, but you can use it as a way to store information on each individual bit. So you can then send 8 pieces of information in just 1 byte. So that's one way to do kind of optimizations, but there's a lot of other things like compressing the data, and there's a lot of things that can happen during that bandwidth optimization part. Also regarding, is this an important event? Should I send it or not? Prioritizing this kind of information. But yeah, of course, you have to take care of, your data structures and algorithms, basically. And surprisingly, you have to deal with a lot of these things that you might study in university and you think you'll never use them again, but and you'll never use them in online programming, but you end up using a lot of things that they intersect with graphics as well. For example, the same kind of data structures that are used here and there, because at the end of the day, you're also dealing with locations in the world and 3D points, and you have to make measurements. How close this 3D point is to another point in the world, and there are data structures for that to do it efficiently and stuff. So yeah, you care about each cycle, hopefully, of your processor working, but also about the bandwidth, because that is surprisingly where the cost sometimes comes from. Because and if your game is running in some cloud infrastructure, for example, the servers, or even locally, you have a lot of data traveling around, and once you travel between different continents as well, the cost of that increases. So you need to watch out for all of these things, and try to reduce the bandwidth as much as possible without sacrificing the game. Right. And yeah, that's a key part of what we do.
I'd recommend, if you're it's not about gaming as such, but Olaf Elbehaedi, we did an interview with him a long time ago about programming in general, when this was called the Fika Sessions. Just go back in the feed and you can find it. But he talked about, like you were talking about, this information, like you could send 8 bits in 1 byte and stuff. We talked about patching games. Similar, how it compares and analyzes everything. Okay, so what bytes do I actually need to replace? What bits do I need to replace? Which is also much more straightforward, I guess. Sorry, if it's much more complicated than I could possibly imagine. But it's still the constant comparison between one thing and another thing.
Yeah, exactly.
Now, one thing that I kind of want to bring up is, because I've watched some GDC talks on programming, basically not understanding what they were talking about.
Maybe you watched an episode of the Fika Sessions with Olaf Elbehaedi talking about programming.
Yeah, which you should do. No, but programming, you're programming in a language, meaning you have a set language that provides functions that you then use. But then I've heard this expression that, yes, programming is a language, but every programmer speaks with a different accent. And every programmer is not only like Shakespeare writing a new book. He's also like creating a bunch of the words and sentence structures as he goes along. So it's like, it sounds so complicated.
Yeah, I mean, it can get complicated, but
I love how casually you said that.
Yeah.
It can get complicated.
It can get complicated. Like if you like we can talk about a little bit about what this part with the programming languages. The thing is about programming languages is that they're just a tool at the end of the day. You can if you're crazy enough, you can go ahead and write zeros and ones and the computer will understand you. But nobody does that because it will take a long time. So we invented kind of a higher level representation, and then higher and then higher, and then we have what's the high level language we use right now. You can take C++ or Java or any of these things, and they were created to help solve certain problems. So it's not it's not a great thing if you become like brainwashed by just using a certain language, that this is the thing I need to speak basically for all my tasks, because sometimes it's more complicated than what I want to do. For example, take Python, for example. It's a really nice language that you can quickly prototype with ideas in your head. You don't really need to write this very complex C++ code that needs to compile forever and things like that just to get your idea across. So it's important to learn different programming languages and become fluent in them. But that takes time, of course. But yeah, the problem sometimes is that people, sometimes they forget about that programming is also kind of the logic behind what you're doing. So the programming language is just a tool to arrive, to make that logic that you had in your head come to life, basically. So it doesn't really matter what programming language you use. It's more about the logic. So how you think in terms of like flow charts and stuff. How if this happens, this is then happens, or else this happens, and so on. So this kind of logic is what's really important. And I try to encourage people to really focus on that more than the programming language, because if you understand this, if you know what you want to do, then you can use any programming language to arrive at the final product. Of course, here in the game industry, we care about performance and stuff. So you would find a lot of projects that use C++, and it's just because it's down to the metal kind of language. It doesn't have a lot of things that are like garbage collection and things that help you avoid errors. Basically, you have to do it yourself.
Yeah, just be perfect.
You just have to be perfect. So it's a lot of these things, and we can maybe talk about what makes beautiful code if you...
Yeah, I just want to mention that though you use the word logic, and when I tried over 20 years ago now to learn any form of coding, the logic was one of the big hurdles.
Yeah.
Not the only hurdle, obviously, since I was terrible at it, but the logic in itself, like approaching it with a programmer's logic, it was for me really difficult.
Yeah. That kind of requires some training, and it also helps if you attack it from by learning more into mathematics. So understanding like logical reasoning, and there's a whole branch of mathematics called discrete mathematics, which helps a lot with this logical computations, and things, and proving things that, I wrote this algorithm, but can you prove it that it will never break or, reach a state where it deadlocks and nothing continues? It just holds there forever. So having some mathematical background helps a little bit with the logic part.
This explains so much. Why I had issues. Good to know. I feel less bad now. Sorry.
Yeah, but I mean, it's just people sometimes are also afraid of math, so they don't get too much into it. But yeah, I mean, I think this is really critical for you to be a really good programmer is to have the math right there.
But is this the logic and stuff to touch briefly upon the code is beautiful part? Yep. Is that how it flows from the logic and the
Yeah, I mean,
electrical currents and all that.
yeah, there's a few things that I consider, and it's kind of like everybody has their own opinion about it. But what I consider as beautiful code is code that is to the point. It doesn't use more features of the language than what's required, because in C++, you can write code that can appear as completely alien language to some people who don't know it. Even C++ programmers, you can always throw at them something that they don't know. That's especially the case in C++. But if you're doing that, just for the sake of showing off, then it's not that great. So if you know exactly what feature of the language you're using for this specific task, then you're being concise and you're being to the point. And also, code that has, of course, meaningful names. You're not finding random this person's name in the code as a variable that you're storing things in. Of course, yeah, you'd find that in university level sometimes, but yeah, meaningful names. And to me, the best part is when you read somebody's code and you see that they are taking into account the architecture of the computer that this code is supposed to run on. So they're taking into account the memory architecture. They're taking into account the different CPU caches and the GPU caches, and it's all in how they wrote the code, in how they wrote this for loop, and how they wrote these specific conditions to avoid checking using an if condition or not. That to me is beautiful. And sometimes to arrive at really elegant code, you need to actually prove it using mathematics. Otherwise, you'll end up having a lot of spaghetti stuff.
This is why I love talking to programmers.
Yeah,
that's why I'm just completely silent right now. I think it's wonderful to listen to, because again, we touched upon it. Like when you hear programmers talk about this, and we see it in you now as well. If you're watching the YouTube version, that is kind of like the passion in the eyes of programmers when they talk about this stuff. So I could have listened to this for an hour.
Yeah, and also like the philosophy of what you just said about beauty in code, I feel fits perfectly for an online programmer, because it is about making the code as streamlined and without fluff as possible, because you need to, like you said, send it back and forth. And
it's hardware all the time with the...
Yeah. You have to think about these bytes all the time.
You can't. We have tears in our eyes. But if now, like, we're fascinated now. I've given up on my programming career, but
don't.
that didn't even start. But we probably have listeners and viewers that are very interested in programming. Mm-hmm. Maybe some of them have started, maybe some of them are brand new. Do you have any tips for them where to go and how to like move forward with their programming?
Yeah. I would, of course, I would suggest that, if you have the opportunity to pursue a degree in computer science, that would be the best thing. But also on the side, you can be self-teaching yourself a lot of things. And if you want to work in the game industry, now it's like there's no excuse for not being able to learn any of the things we talked about today. You can read books, and there are a lot of books that I can suggest regarding C++. For example, you have the Tour of C++ by the inventor of the language himself, Bjorn Strostrup, and you also have the C++ template complete guidebook, which is like an 800 pages book about a specific feature of the language. And that you can tell why it can get complicated. But these are two books that I suggest to anybody to read and sort of get an overview of C++, for example, which is a more relevant language to the industry. Then I would suggest also learning about like computer architecture, like what is inside the CPU, the different caching, the different caches in the CPU, and how the CPU interacts with the memory. Why is it a slow thing? Why Why is it slow to move data from your CPU or from your RAM to the GPU RAM? All of these things you'll find a lot of lectures online, and there are a lot of books as well. And nowadays you can even ask ChatGPT or GPT-4 if you're asking for kind of tips on what to read and stuff. And there's a lot of game engines out there. Of course, Unity and Unreal Engine. All of these architectural things we talked about. With when to send packets or not, reliable versus unreliable, and all of these things, you can basically go ahead and learn them, and you'll become relevant right away to the stuff we're doing here as well. And there are a lot of tools, and I think that every programmer should be make themselves familiar with stuff like profilers, which basically they look at your code, they try to measure how much time it takes in each function, for example, and then getting really good with these tools will help you eliminate a lot of problems down the line in your job when you're trying to optimize things. And you don't want to be learning tools at that point. No, you should come in with the information, and it's out there. Something like Entel VTune, for example, it's completely free, and people can use it to learn this kind of information. Something that we're moving towards because of the cloud architecture and leveraging the cloud and stuff is Docker containers. That is something that people should also learn about. Not a lot of universities teach it, when you're in university, but containerization and orchestration of workloads on the cloud and stuff, that is a very important topic as well, that people can learn a lot on Coursera or any other platform. And you have tools for observability. Once you have your things on the cloud, how can you monitor what your program is doing and stuff? So there are tools like Prometheus, which collects data metrics from your application. And there's like dashboards like Grafana, for example, that you can display these things in terms of graphs. And all of these are open source tools. You can go ahead and use them and learn about them. And they're very vital to any company out there, whether it's games, fintech, as my previous company, any kind of industry, you'll have these tools sort of there, maybe with different programming languages, but they'll always be there. Profiling, observability, stuff like that.
I love that. Not only how to get going and started, but a path towards specializations that will be valuable in the future.
Once upon a time, I was told that learning PowerPoint is a really good thing because not enough people know PowerPoint. And now this. But links in the description.
Yeah, we can put that.
Yep.
Yeah, I think that's it for now. I mean, the well is deep. We've glossed over a lot of deep holes where we could have dived in and talked for hours and hours.
Yep.
But we want to keep it snappy and consumable. But thank you so much for your time, Omar. It's been an absolute pleasure, and shown a light on a lot of stuff that I've been wondering about. Specifically, don't complain about netcode, or at least not using that term, because it's not a term that actually really exists. But yeah, thank you so much, and
thank you very much, everyone.
See you on the next one.
Bye.